neutrons, and electrons. Okay, now we have the new topic today. This was a topic we discussed earlier about the electron, proton, and neutron. That was a new model of the atom. Okay, now we are going to start a new one today, that is more on subatomic particles. Okay, what are the subatomic particles? The proton, the neutron, and the electron. What are more on these particles? On these particles, first of all, we are having their relative masses and their charges. Okay, the relative mass mean that electron, neutron, and proton, what is their relative mass to one another? What is their relative weight to one another? Okay, so relative mass is 1. Okay, the relative mass of proton is 1. The relative mass of neutron is also 1. But the relative mass of electron is 1 upon 1840. It is very, very, very tiny and very negligible mass as compared to proton and as compared to neutron. The mass of electron is 1 upon 1840. It is a very, you can say, it is very much negligible mass. The charges on proton is +1 charge. The charge on neutron is 0 charge. There is no charge. And the charge on electron is -1. Okay, the charge on proton is +1. The charge on neutron is nil, no charge, 0 charge, and the charge on the electron is -1. Okay, so actually when you see to the masses, their masses are very tiny and negligible. It means that the weight of electron, proton, and neutron are negligible weights, negligible masses, and almost all the mass of an atom is present in its nucleus. And what are present in the nucleus? In the nucleus, proton and neutron are present. Electron revolve around the nucleus. So inside the nucleus, and the proton and neutron are making the mass of the atom, and it is present in its nucleus. But as compared to an atom, the mass of the nucleus is very tiny, and you can say very, very, very small. Okay, imagine an atom is the size of a football ground. Okay, so its nucleus will be like the football present in that ground, or you can say even smaller than the football as well. So it is very much smaller mass. The atom is very big. As compared to the atom, the nucleus is very small, but all the mass of the atom is present in its nucleus. The remaining space of the nucleus is empty. Okay, it means that the nucleus have a very high density. Density means mass divided by volume. Okay, the volume is very big, but the mass is very negligible. So the nucleus is having very high density. Okay, it is very much smaller as compared to the size of the atom. Okay, and again, if we can imagine it, like for example, we can imagine it as a football ground, we can imagine it as a cricket ground, and we can imagine the ball of football or the cricket inside that stadium. That is the nucleus. So the nucleus is very much smaller as compared to the atom itself. Okay, now atoms have no electrical charge. Overall, atoms do not have any kind of charge. Okay, but we know that atom has some charged particles in them. Like for example, electron is negatively charged, proton is positively charged. Okay, but overall the atom do not have any kind of electrical charge. It is neutral. An atom is neutral. Now why it is neutral? It is neutral because the number of proton is the same as the number of electron. It means the positive particles are same as the negative particles. Okay, like if for example the positive particles are 2, so the negative particles are also 2, and we know that when there are two values which are same but opposite in their signs, opposite in their mathematical signs, so they can cancel each other. When they cancel each other, so the overall charge on the atom become neutral. So there is no charge on the atom. Overall, there is no charge on the atom, okay? But particularly on the electron, there is a negative charge. On the proton, there is a positive charge. The electron and proton are equal in an atom. Whatever atom is it is, okay? If there is 2 number of proton, there will be 2 number of electron in them. So they will cancel each other. When they cancel each other, their charge become neutral. They become neutral. There is no charge present on the atom. Okay, see here, this is the diagram I'm telling you. You can see the electrons. The electrons are negative. Okay, the protons are the positive ones. There are 2 electrons and 2 protons. So the electrons and the proton cancels each other. When they cancels each other, what lifts? Neutron lifts. So the neutron have no charge. So atom does not have any kind of charge present on them. Okay, now we are moving back to the screen. If there is any question, now you can ask. In the middle, I'm telling you people time and again, in the middle, you are not supposed to ask any kind of question to interrupt the lecture. I'm giving you time now. Every time I give you time. Okay, now if you have any question right now regarding the topic we have discussed right now, you can ask the question so that we can move to the next topic.
Sir?
Ji.
Sir, the number of protons and electrons is always same.
They're always same. Like for example, if we are having an atom of nitrogen, okay, so their number of proton and number of electron will be same. If we are having an atom of oxygen, so their number of proton and electron will be same. So every atom has the same number of proton and electron. So they cancel each other. When they cancel each other, the atom becomes neutral. Any other question? Is there any other question from anybody?
Sir, can you explain it again?
Explain what again?
Sir, the concept of electron and neutron and protons.
That I told you that electron is negatively charged particle, proton is a positively charged particle, and neutron does not have any kind of charge on it. Okay, so the number of electron and the number of proton are same, always same in an atom. So they normally cancels out each other. When they cancels out each other, so they become neutral.
Okay, sir.
For Mera Khan, we already discussed that atoms are charged. It means that they have positive, negative, and neutral particles. Huh? These are the particles which were described and discovered by scientists. We will study further. The next topic is regarding electrons. We will discuss that. And then we will discuss the neutron and proton as well. So, okay. Now we are moving to the next topic, okay? Again, let's see. This was the topic which we discussed, that there are protons and neutrons which are in the center of the nucleus. We have electrons which are revolving in the shell. The electrons and protons are same in number but opposite in charge, so they cancels out each other. When they cancels out each other, so their overall charge become neutral. There is no charge on the atom. Let's see topic number 2, finding electrons. Okay, now we are going to see that how the scientists have discovered the different particles. So first of all, we are going to see how the scientists have discovered electrons. Let's see how they discovered electrons. Now, finding electrons. In the late 1800s, scientists investigated some gases. Okay, they have experimented some gases, and for that purpose, they took a sealed tubes containing tiny amount of gases in them. They were kind of vacuums. They took some vacuums, and in those vacuums, there were small amount of gases present in them. Okay, then what they did, they set up electrical circuits and supplied a huge current and huge voltages to that tube. Okay, that sealed tube were supplied with electrical charges, electrical voltages, and amazingly, they saw that the gases conducted electricity. So as the gases conducted electricity, different scientists gave their predictions. Like for example, in 1869, John Hathorpe noticed a green glow on the screen. They have presented a screen with that. Okay, there was a fluorescent screen, and John Hathorpe noticed that as we passes the current, the voltage, the gas start moving, and when the gas start moving and it strikes the screen, it glows. Okay, it produces a green glow on the screen. Then he said that the glow is caused by rays from the negative electrodes. There are two electrodes, one is positive, one is negative. When we are passing on the current from something, so we normally have two kinds of electrodes. One is the positive electrode, the other is the negative electrode. So the positive electrode is basically connected with the positive terminal, and negative electrode is connected with the negative terminal of the battery or the current. Okay, so he said that the glow is caused by rays from the negative electrodes. Okay, the rays travel through the gas and it hit the screen. He said that the rays traveled through the gas and it hit the screen. So he named these rays as cathode rays. Now the investigation started. In 1800, the scientists started investigation on some gases, and for that purpose, they took certain kinds of vacuum tubes, and in that tubes they produce some kind of gases in them, and then they produce a kind of electric current, and electric circuit passed from that. So when they passed the electric current, the huge electric current, they saw that the gases conducted electricity. Okay, in 1869, John Hathorpe noticed that a green glow on the screen is presented. So he said that the glow is caused by rays, and the rays are basically traveling from negative electrodes. Okay, the rays travel through the gas and hit the screen, and the scientist named these rays as cathode rays. Now let's see what kind of setup they have produced. This is the setup which they have produced. See here, this is the kind of setup. You can see a tube here. This is known as discharge tube. In this tube, you can see at the end there is a screen present. There is a pump present, vacuum pump present, a negative electrode and a positive electrode is present, and a battery is connected with that. So as it passes on the current is basically rays were formed, and the rays were formed from the negative electrode as they were moving toward the positive ones. So as they strike the screen, a green glow was produced. You can see the green glow. I'm going to show this to you people in the animation as well. Okay, I'm going to show you people with the animations that how this process was basically taken place. Okay, so first of all, you can ask me any question right now. If you have any, then I'm going to show you people about the animation as well. If there is any question.
No, sir.
First of all, is there any question? No question. I'm going to show you people the animation.
Sir,
Yes.
कैथोड रेस के बारे में थोड़ा और बता दें, वो क्या है?
Cathode are basically rays. We will discuss further as well. Okay, wait a bit. We'll discuss further as well. I'm going to show you people an animation of the cathode ray. Okay, how the experiment was being presented. Okay, now see, this was the kind of setup. This was the setup which they presented. Okay, this was the setup which they presented. Now, what happened when they put this setup? See, here is a high voltage. You can see electrodes are present. Okay, now they are going to turn on. When they turn it on, what happens? The current starts flowing. When the current starts flowing, you will see that the rays are being emitting, and the rays emits and it goes and strikes what? It goes and strikes the fluorescent screen. And as it strikes the fluorescent screen, what is happening? It is producing a green glow over here. Okay, it is producing a green glow. So the rays which are basically emitting from cathode, they're moving towards the anode and going to strike the fluorescent screen. They are known as cathode rays. Why they are called cathode rays? They are called cathode rays because they are emitting from the cathode. They are emitting from the negative pole. Cathode is the negative pole. Okay. pole, and they are going towards where? And they are going towards the fluorescent screen, and striking upon the fluorescent screen, what they are finding out that there is a glow. You can see the green glow when they strike the fluorescent screen. Okay, so now we are moving toward the screen back. If there is any kind of question, again, you can ask. Okay, is there any question now? Anode is the positive electrode. Basically, there are two kinds of electrode. One is negative, other is positive. So cathode is the negative, and anode is the positive one. That green glow is basically of cathode rays. They presented it on the screen. Okay, as it strike the screen, a green glow was presenting. Anode is the positive electrode. Electrode means where we connect the electric currents. So one is the negative current, the other is the positive current. Okay, so the negative one is the cathode and the positive one is the anode. Clear?
Sir, what is that green light?
That green light is cathode rays.
Okay, sir.
As it strike the screen, it produces fluorescent. So they call them cathode rays. Any other? We can move on.
Okay.
Safai will provide you people the recorded lectures, okay? I will give you the recorded lecture. You can listen to that as well. Okay, so now we are going to the next one, okay? Turn off your mics, all of you. Turn off your mics. Still somebody has his mic on. Kindly turn off the mic. Okay. Now we are going to the next topic again. We are going to see it further as well. Now they have investigated some things. What were their investigations? We have seen here that as they passes on the current, you see a positive and negative particle over there. So the negative particle, the negative electrode start the rays, and the rays was passing the positive and it was striking the fluorescent screen, and here it was producing fluorescence. Okay, it means that it was glowing. Fluorescence means it was glowing over here. So from this, John Hattoff said that it is basically cathode rays, and the cathode rays are basically negative particles. Now let's see what further the scientists thought about them. Now Joseph John Thomson, J.J. Thomson work. Okay, J.J. Thomson thought about the cathode rays. Now they have discovered the cathode rays. So J.J. Thomson thought about these rays, and he suggested that cathode rays may be electrically charged. Okay, he suggested that these rays may be electrically charged. So he collected evidence to test his idea. I will show you the animation again through which he collected his idea that cathode rays are electrically charged. He passed cathode rays between electrically charged pieces of metal. One positive charged piece, the other negatively charged piece, okay? And then he observed that the rays bends toward the positively charged metal. So we know the concept that the negative particle normally are attracted by the positive one. The positive particles can be attracted by the negative one. They are charges. Positive charge attract the negative charge attract the positive charge. So what happens over here? The rays which were moving on and they were bending towards the positive charged metal, he said that there are particles and these particles are basically charged. Okay, so he told us that cathode rays are negatively charged particles. Okay, then he collected more evidence and he concluded that cathode rays are made up of materials, particles. Okay, he told us that cathode rays are made up of particles, and all the particles have same tiny mass and same electric charge. It means the mass of each and every particle is same. Okay, and the charge on each and every particle is also the same. That charge is negative. So by the year 1897, J.J. Thomson discovered the first subatomic particle, that is the electron. And the electron is negatively charged particle. The electron is negatively charged particle. So the cathode rays, the evidence about the cathode rays suggested that an atom is having a negatively charged particle, and that negatively charged particle was named as electron. So it was a huge investigation to go to a conclusion that how the electrons are being formed and how the electrons are being discovered. So the electrons were discovered by Joseph John Thomson, or in short we call him J.J. Thomson. He is the discoverer of the electrons. Okay, so now I'm presenting you one more thing. See here again, I'm presenting one thing that you should see, which is going to tell you how was this happening. Okay, so this was the earlier we said they were saying that the cathode rays are moving. It is crossing the anode and it is going toward the fluorescent screen and striking over there and producing a green glow. Okay, now we have to see the work of J.J. Thomson. What J.J. Thomson did? J.J. Thomson put the metallic pieces, one positive metal, one negative metal, to check what kind of rays they are, what kind of particles they are. So what did he do? See, now what is he doing? He's going to put the metallic particle, the metallic plates over here. See what the metallic plates are. You will see the metallic plates now. Applying electric field to this. Okay, now these are the atomic electrical field. You can see, and it is changing toward the, as you can see over here, that J.J. Thomson put two metals. One is the negative, the second is the positive. Okay, so the rays bent toward the positive. The rays bent toward the positive side. Why the rays bent toward the positive side? Because they were negative rays. So negative rays are going to bend toward the positive. Okay, toward the positive side. If the rays were positive, they would have bent toward the negative plate or the negative metals. So from this experiment, J.J. Thomson investigated and he proved that cathode rays are material particles, cathode rays are negative, and they move toward the positive electrodes. It means that they are going to strike the positive side of the electrode. So this is how the electron was being discovered. Let's move back toward the screen. If there is any question, so you can ask your question right now. Okay, now anybody's question? Now you can ask the question. If you can turn on your mic and ask the question as well. You can write in the comment as well. Okay, Horen. Yes, any question? So all is clear now? Cathode rays are always negative. Yes, they are always negative. Okay, and the cathode rays lead to the discovery of electrons. So first atomic particle, that was electron, was discovered after this experiment, and they told us that cathode rays are negative. So the atom must have a kind of negative particle in them, and then that negative particle was named as electron. So hope it's done. Now,
Sir, electrons is also negative now.
yeah, that's what we are discussing. Cathode rays lead to the discovery of electrons. Cathode rays are negative, electrons are also negative. Done?
Yes.
Okay. Okay, now, next we are going toward the next topic. That's now I'm presenting again. The next topic now. Okay, so this was Joseph John Thomson work. Okay, Joseph John Thomson or J.J. Thomson were scientists who discovered electron, and the discovery of electron led to a lot of other things as well. Let's see what happened further. Now, after presented, the scientists thought about these electrons, which were discovered by J.J. Thomson. They knew that electrons come from materials. How they come from material? Because they're coming from cathode rays. They also knew that materials are made up of atoms. Each and everything in the universe, each and every material in the universe is made up of atoms. Okay, so atoms are the smallest particles of matter. The matters are made up of atoms. So they concluded that electrons must be the part of an atom because they are material particles. They are coming from materials, and we know that all material is made up of atoms. So it means that electrons are the essential part. Students, can you tell me, is the screen visible to you people?
Yes, sir.
Yes, sir.
Yes.
Okay, good.
Yes.
So what the scientists concluded? They concluded that electrons must be the part of the atom. So they suggested new models for atom. And what that new models were, the first model was presented by J.J. Thomson. Let's see what J.J. Thomson model was. J.J. Thomson model was known as PLUM pudding model. Okay, and plum pudding, you know, plum is you can call that the kishmish, and the pudding is the cake, kind of cake in which the kishmish are present. Okay, so J.J. Thomson knew that electrons are negatively charged. Definitely, he discovered that, and he knew that electrons are negatively charged. He also knew that atoms have no overall electrical charge. Okay, that we already discussed, that atom have no charge. Okay. Two evidences to suggest a new atomic model. According to the model of J.J. Thomson, he told us that negatively charged electrons are placed throughout a positively charged sphere. Okay. According to this model, negatively charged electrons are placed throughout a positively charged sphere. Until now, we haven't discussed the positively charged particles. Positively charged particles are protons. We'll discuss that as well. So according to Thomson-PLUM pudding model, the negatively charged electrons are placed throughout a positively charged sphere, and the electron moves around in ring like plum in a pudding. And the cake, as the kishmish are present, similarly the plums are present, similarly the electron are also moving in a ring. Pudding model. Let's see what was plum pudding model. Okay, this is plum pudding model. This was the actual model. This is the actual model which J.J. Thomson told us, and that is plum pudding. Okay, like a cake, you cut it down, and in the center you see that it's like this. जो किशमिश होते हैं केक के अंदर वो इस तरह से प्रेजेंट होते हैं, like this one. Okay, so this is known as plum pudding model of electron. Clear?
सर ये ऑरेंज ऑरेंज क्या है?
The orange, this one is the atom, the atomic model. This one is the atomic model. According to him, he said that the electron are present in the positive sphere. That yellow one is the sphere, is the positive sphere, and the electrons are moving in it like this one. Okay, so this is just like a plum in a pudding. So the people call it plum pudding model.
सर ये ब्राउन वाले के अंदर जो स्पॉट्स हैं वो क्या है?
ये किशमिश है ना, प्लम्स है बेटा. ये ब्राउन वाला केक है, केक पुडिंग है.
ओके सर.
सर आवाज नहीं आ रही.
Okay. Now, if you have any kind of question, you can come and ask now.
सर ये प्लम पुडिंग वाला समझ में नहीं आया.